All right, two special right triangles we should know, 30, 60, 90, and the 45, 45, 90. With the 30, 60, 90, it's easiest if we know the leg opposite 30 degrees. Let's call that x. If we know that that side is x, the longer leg across from 60 would be x times the square root of 3. And the hypotenuse would be 2 times the value of x. For our 45, 45, 90 triangle, our two legs will be congruent, and our hypotenuse will be that value times the square root of 2. Two examples here with the 30, 60, 90. The triangle on the left, we know the short side across from 30. Knowing this, we can identify that the long leg would be 5 times the square root of 3, and the hypotenuse would be 2 times 5, or 10. All right, same thing for the triangle on the right. It's a little bit smaller. We know the hypotenuse this time, which means we could find the short leg by dividing by 2. So 8 divided by 2 would be 4, which means the side across from 60 will be 4 times the square root of 3. All right, so problems that you might get when you see, when you're thinking about special right triangles, and we'll lead into talking about the unit circle and how this also applies. You might be given a problem that says find the sine of 60 degrees. Okay, so we're going to do this actually with both triangles here, and I'm going to show you that it doesn't matter which 30, 60, 90 triangle you have. It doesn't matter the size, that you should get the same answer. So on the left here, think about the sine of 60 degrees from this 60-degree angle. All right, our sine is our opposite side, which would be 5 square root of 3, divided by the hypotenuse, which is 10. Notice that this can reduce. We can reduce to 5 over 10, and that's the same thing as square root of 3 over 2. Okay, so same problem on the right, where we also have our 30, 60, 90. And now when we look at the side across from 60, we have 4 root 3 divided by the hypotenuse is 8. So notice, again, when we reduce that fraction, we just get the square root of 3 over 2. So what we see here, whenever you're talking about a 30, 60, 90, or whenever you see a trig function with an angle measure here, all right, because I know if I'm using one of these trig functions, we have to have a right triangle. So you're locking down the right angle, and we're locking down the 60-degree angle. So if I know that two angles have to be the same in the triangle compared to another triangle, I know that third angle would also have to be the same. So every single 30, 60, 90, think about just dragging that triangle, making it bigger or smaller, will all be proportional to each other. That means their side ratios will all be equal. So that's why it doesn't matter which 30, 60, 90 I draw to answer something like the sine of 60 degrees. I'm getting an answer that's a side ratio, so I know when I reduce, they'll all be the same thing. Because our special right triangles are so popular and they pop up all the time in the real world, we have a tool to help us remember their ratios. So the unit circle is our tool. We're only going to worry about the first quadrant for right now, where these values come from. So remember how we talked about opening an angle in center position? That's how we're going to think about this to start with. So we've got our initial side on the positive x-axis, and I'm going to open up 30 degrees. Okay, so this is 30 degrees. And I'm going to drop a perpendicular to form a triangle. So I've got a right angle right here. So with a unit circle, the base definition is that we have a radius of 1, and we put the center of the circle at the origin. With this, I just drew this 30-degree angle coming from the origin. So now we have a 30, 60, 90 triangle, and if the radius is 1, that means the hypotenuse for the triangle I drew is 1. And since we have a 30, 60, 90, we can now think about, if we know the hypotenuse is 1, that means the short leg must have to be 1/2. And then the long leg across from 60 would have to be 1/2 times root 3, or root 3 over 2. So when we think about our unit circle, the coordinates around the circle are actually the sides of our triangle. So for this 30 degrees, we just found that we had to move over root 3 over 2 to get to where this point is on our x-axis. So our x value is root 3 over 2. Our y value, we would be up 1/2. Okay, so that's our first special coordinate that we need to know, coming from our 30, 60, 90. All right, our next special value would be thinking about the 45-degree angle of our 45, 45, 90 right triangle. So this angle is 45 degrees. We're going to drop the perpendicular, have a right angle here. And now same rules apply, so our radius is still 1. And if we know that our radius is 1, to get to the sides of a 45, 45, 90, we would divide by the square root of 2. So 1 divided by the square root of 2, which if we rationalize is the same thing as the square root of 2 over 2. That's our base, which also means it's our vertical side here. So thinking about this coordinate, all right, when we think about 45 degrees, we're going to have the side ratios of root 2 over 2, root 2 over 2. All right, the last one we need to know would be if we opened up 60 degrees. So about right here. All right, drop our perpendicular. Here's our right angle, 60 degrees. We still know our radius is 1. And so that means we would know our short leg is also 1/2. Divide that 1 by 2. Our long leg is 1/2 times the square root of 3, so root 3 over 2. So think about this coordinate. We would have over 1/2 up root 3 over 2. All right, we want to be able to memorize this first quadrant. It's going to help you know the whole circle. We'll talk about how we get the other values knowing the first quadrant. Just to give you a basic idea of using this, let's do this example here. We're finding all 6 trig functions for pi over 6. So we'll start with sine of pi over 6 and cosine of pi over 6 and tangent of pi over 6. Okay, once we find those 3, our other 3 trig functions are just these reciprocals. So for pi over 6, that's the same thing as 30 degrees. I'm going to highlight here. All right, we're really talking about this triangle, where this is 30 degrees, 90, and 60. So if we want the sine, we want the opposite side over the hypotenuse. So remember, for all of these, the hypotenuse is just 1. So if I think about the opposite, well, I know that that corresponds with the height right here, or the y value. And the adjacent corresponds with being over root 3 over 2, pulling those from that coordinate. So if we wanted the sine, we would want to divide 1/2 by 1, which is just 1/2. If we wanted the cosine, the adjacent over the hypotenuse, we would divide root 3 over 2 by 1, which is just root 3 over 2. So notice, with this triangle, because our hypotenuse is just 1, we really have the cosine, just looking at the x value, and the sine just by looking at the y value. And that's going to be true for every coordinate when we're talking about the unit circle, because we have a radius of 1. Tangent, all right, that's typically the opposite divided by the adjacent. Okay, we'll clean that up a little bit, but keep in mind that would be the same thing as taking the y value and dividing by the x value. So to clean that up, 1/2 times 2 over root 3. All right, that's just 1 over root 3. We can rationalize, that's root 3 over 3. All right, to get to our cosecant of pi over 6, we can just flip sine, since cosecant is the reciprocal of sine, and we would get a positive 2. And to get to secant, we need to flip cosine, so that would be 2 over root 3, which is the same thing as 2 root 3 over 3. And then to get to cotangent, our last trig function here of pi over 6, we need to flip root 3 over 3, which, or I could look right here before We rationalize for tangent, and I can flip root 3 over 1 and just get root 3. So we'll talk more in class about how to use the unit circle. Here's just a taste or a refresher.